meeting is being recorded.
Okay. I wanted to try. Should we start? I think we should start. Or wait for a couple more minutes. Let's see.
This meeting is being recorded.
Hello, everyone. So this is Batch Working Group, July 7th. This meeting is recorded and will be uploaded to YouTube. So please adhere to Kubernetes guidelines when commenting. So today we have Atanas. So he'll be giving us, they'll be giving us an overview of Slurm. So Slurm is a batch, a known batch scheduler. I believe it has a lot of history with HPC type workloads. So Atanas, please take it away.
Thanks, Abdullah. Let me try to share my screen. Hopefully everything works fine. It's telling me host disable screen sharing, if you can enable
Yeah, make co-host. Yes. Try again.
I think looks good. Let me know when you see my slides.
Yeah, I can see you.
Okay. Yeah, thank you everybody for joining this talk today. I participated some of the previous calls in the batch group, and I heard interesting topics in respect to batch job submission on Kubernetes. And my background before going to the cloud native site was HPC, and basically we used a lot, basically in high performance computing, we have similar problems what people have to deal with in Kubernetes nowadays. So we are having distributed computing, and a lot of the workloads are processed in a batch job manner. There are different solutions how to do the scheduling and resource management. And very popular, of course, is Slurm. So I thought it would be a nice kind of thing to share what was done in HPC with the community here. If you're developing new tools, maybe this will give you an idea for nice interfaces, or idea how to extend existing tools, make them cloud ready and so on. So I think, I hope it will be valuable for everybody. Let's jump into the details a little bit. What is Slurm? So Slurm had long history. It started development in 2002 in Lawrence Livermore National Laboratory. And you see already a little bit about the history in the name. It was simple Linux utility for resource management. Actually, the first version of Slurm was a resource management tool. It was still not having a lot of scheduling capabilities, but this was the start. It's a C code, quite good size C code, 500,000 lines of code. If you compare it to other tools, I don't know how big Kubernetes is, for example, but it's quite compact for the tasks what it has to deal with. and very efficient. If you have used it in the past on the HPC systems, you must probably aware that the tool can scale to thousands of nodes. Basically, can submit. You can run jobs on thousands of nodes, and basically the deployment time or the time to start the job usually on such kinds of clusters is within a minute. What I heard in the past. So it's really quite optimal solution. So you can find details more about the actual software in the link below. But I tried to capture some key points and give you some overview what Slurm is and can do. So just have to deal with PowerPoint, right? So yeah, Slurm had very simple original idea. Basically, it tried to coming out from normal applications on PC. When it was developed, 2002, this was just the time where parallel applications were getting more important. We got in the time of the first multi-core processors and so on. So basically the idea is how can we run parallel applications in a similar way like we do it on standard PC. You see an example, you have an Linux application, some application A, and you want to execute it on Linux. This is very simple, you just call the application, and Slurm, in Slurm you can execute a version of such application just with a single command srun, and you're running a parallel application, and 8 tells that you want to run 8 copies of that application. So it's quite intuitive idea, let's say. And in HPC, usually behind the A stays a MPI parallel application. MPI is, in that case, message passing interface. So you have multiple processes which are communicating through messages. This was the main idea, what they want to achieve originally. And yeah, the tool became quite big and offered a lot of additional features. It's fault tolerant, full scale cluster management tool. Basically, it has 3 main things. You can use it as a resource manager. So it can deal with all the resources available on the compute hardware, allocate them, free them according to job requests. You could define certain time limits, how long your job should be running. After that, the job will be kicked off. And it provides all these components, what you need to start the jobs, execute them. It has monitoring utilities. A lot of the tools which are part of the package are command line tools, which makes it very nice for administrators. It's less graphical compared to what you see nowadays with Kubernetes and so on. But very interesting concepts are the queues. So we will talk about that a little bit later. Right, and just I found this kind of information from SCATMD. SCATMD is the original company or community which currently drives the development of Slurm. And they gave a short overview what is the difference between resource management and job scheduling. I think most probably everybody in this community is aware of that. Resource management, how do you allocate resources on the compute nodes? So resources can be cores, memory, caches, networks, GPUs, switches, so many things are seen as resources. And job scheduling is, yeah, how can you schedule your jobs more optimal if you have complex network topologies, if you have time slices, if you want to limit the execution of jobs. Let's say we have in my company the case we want to restrict jobs of users to be no longer than 2 days. So you could do that with Slurm. You can set such kind of limits, and you can do prioritization, different quality of service, different priorities. Yeah, it's quite powerful. Actually, there are more solutions out there for that. You see below some small kind of table. Slurm covers both resource management and scheduling aspects. And if you ask yourself what's Kubernetes, today Kubernetes also covers both resource management and scheduling. So it's another kind of bar in this table. Looking behind the architecture, so basically on this diagram, let's start with this box with the lila color. Those are the main components. There is a control plane, Slurm control daemon, basically. Resembles a little bit the kubectl. So basically, this is the main component with which the users are speaking to issue commands, but also it speaks with the database. This is the Swarm database, which is mostly managing the accounting values, like if you want to introduce users, policies, time limits, those will be stored in the database. And the control daemon will ask for them, or basically they will be pushed back. Then you can have multiple copies of the control daemon if there are more users on the cluster and a single process cannot handle that. You can replicate it, have an optional daemon to handle more work. And then the yellow box basically is run on the compute hardware. You have a Slurm daemon, which is responsible for basically you get the job request from the users. It's registered from the control daemon, and the control daemon sends it to the actual nodes. The actual nodes running the Swarm daemon will take care then for resource allocation and job execution. So the Slurm daemon is something like kubelet if you search for some sort of references or connection to existing Kubernetes architecture. In terms of commands, what the user are using, you can see them in this blue box. Speaking with the control daemon is done with the scontrol, basically. SQ, you can ask what queues are available on the system. You can view the queues if the jobs are queued, how much you have to wait that your job gets running. You can achieve that through the SQ. In queuing, job happens with sbatch. So sbatch is just fire and forget. At some point, you get an output from the job. And then srun is more interactive blocking process. So actually you enqueue a job, you block, or the control daemon is blocking the user request until your job gets running, up and running. It's more like an interactive experience. And there are some further functions for accounting to monitor or to see the accounting values which were stored in the database. This is the basic architectures, how Slurm looks like, resembles a little bit Kubernetes if you think today. So again, in Kubernetes, we have a control plane, we have daemon in the form of kubelet, you have a database, etcd, so very similar. Right, this is a little bit, go ahead.
Just one quick note, yeah. To draw one more comparison here, like all these arrows are RPC calls, right? Mostly.
Those are right. They are residing on different servers. So the database can be a different server. The yellow boxes are all on different servers. You will have one daemon per compute node.
Right. I guess they're trying to mention here, like in Kubernetes, you don't have these calls being explicitly made between components. Like components don't call each other directly. Here they do. Like for example, srun, which is running on the client, it actually makes an RPC call to slurmd, in our case, the kubelet, explicitly to start a job
Right.
specific node. But in
This is
Kubernetes,
impossible.
that is not, right?
Yeah, right. That's good hint. Yes. So there are some differences still, as you see. So yeah. This is a little bit detailed description of, or some bullet points for each component, what it does, the most important components, basically the Slurm controller, so, and then the database, the Slurm daemon, but we captured those. As batch. Some of the basic utilities used to submit jobs are sbatch and srun. Jobs are basically text files, simple text files. I will show an example how such file looks like. But you just call sbatch with this job file, and then all goes to the controller and the job is executed. It's very simple. You can also have something like interactive jobs. You can call srun with some additional arguments to have an interactive job. So it's not completely batch job based. You can have maybe a partition, small partition for interactive usage. And then there are further comments.
One question: Can you explain what's a job allocation?
Job allocation, basically, it's waiting that the resources are allocated. When you get the resources, you get unblocked. And this is the difference. As batch, you will shoot the job, you will enqueue it, put it in a queue, and the command line gets unblocked. Basically, it continues normally, the normal Linux command line. You can use it for whatever you want, but it's not guaranteed that you will have a result. srun will block until you get the resources.
And in this case, like you could run multiple jobs inside an allocation, right?
Right. You can request to block, to allocate 10 nodes, let's say, and run srun with an argument to allocate 10 nodes. It will wait that the 10 nodes are available from the queue for the certain time span. You can provide the time information. I want to allocate those nodes for 10 minutes. So if the nodes are available on the queue and you're the next user who can get them, then you get unblocked at some point, and you can do your work with that. It's interactive access afterward. Sbatch, you put the job on the queue, it's there at some point, but you're unblocked and you just don't get the result. You can ask basically the controller, what's the state of my job through the sq command. You can see if it's running or if it's still in queued state. So you might need to wait until it's executed.
One more thing here, like you mentioned a lot of commands, and it's like one thing, for example, with Kubernetes is that people sometimes like build automation, like they build controllers to do a lot of the work. Right. I'm wondering if this is a usage pattern that you have also with Slurm, or is it mostly that there are physical end users that are actually starting the job, etc. Or is there a pattern where no, we actually have a controller that fires jobs at some regular?
I did not see such thing. Usually there are users submitting jobs. So you don't have some sort of connection to some events. It's not really events driven concept. Most probably you can do some implementation which does that, but maybe Kubernetes and the whole components have better ways to do that if you want to react to an event and stuff like that. Yeah, usually what I saw in the past are actual users submitting jobs. Yeah, you could do maybe some magic with cron jobs and stuff like that, but it's not really nice.
I just would say users will use frameworks like, workflow engines and stuff like that that interact with the batch system. So it's a different model than maybe Kubernetes, but they're sort of an analog.
Right. Yeah, the flow engines, they are going a little bit in the same direction. They have some elements from cron jobs and stuff like that. Yeah, yeah. Right, so there are a little bit alternative commands. You can just allocate nodes and attach to them later. This can be done with salloc, sattach. And you see some additional arguments. You can have accounts associated to the whole commands. There are components for permission models and so on. You can give the time spans and so on. So quite, yeah, a lot of features available through the API. Very interesting is to look on the batch files. They are, I saw some examples how you are thinking to define jobs for Kubernetes. And the nice thing about Slurm jobs, they're very compact, you could see what you need to express a batch job maybe through this example. So basically, you have a name of the batch job. You can tell how many nodes you need. You can have different number of tasks. The task can be you can assign also how many CPUs you want per task, how much memory you want per CPU. So you do similar things what you do in your pods, basically with requesting resources. So it's a little bit different. Here the resource requests are inside the batch job. So if you are thinking how to implement this in Kubernetes, you will need to find a way to translate. If you want similar kind of interface, it becomes interesting. How do I translate that to pod requests? So it's a little bit difficult problem. And again, you have time. You can specify that after that. And usually, this part is the job description part, where you have resource requests, some definition of time, and so on. After that, it's usually shell scripting what follows, and you can execute any kind of Linux application inside. Basically, it's a normal shell script following that. In many cases, it was an HPC application, and usually in HPC community, they use this kind of module environments, which is a way to configure. If you have multiple software packages, you can turn on or off some of those through the module environment, which basically under the hood just sets environment variables on the system. In terms of the control, what you could get or what kind of resources you can address, you could theoretically address any piece of hardware what you want. You can address CPUs, how many CPUs you want, how much memory you want. There are extensions for GPUs, and then basically there are also after that, the nodes get also different states. A node basically switches between those states. It's idle, mixed, or allocated. You can basically enforce explicit usage of the node that nobody else can use that node, which is very typical for HPC. People don't like to share there, right? So it's a little bit different compared to cloud world, where you have virtualized resources and you might be not the only one on that node. So then the other interesting things are partitions. I will spend a little bit more time on partitions because I find this concept very nice, how you could distinguish between different types of resources. Or so you could group basically pieces of your cluster in partitions. You can tell this part of the cluster is partition 1, this part is partition 2. Where it's useful, you could imagine, let's say you have a hybrid cluster, you have some CPU only part of the cluster, and then you have GPU only, or a cluster with GPUs. So you could build 2 partitions, and instead of giving access or scheduling to all the nodes and basically allocating some job on which uses more CPU on a GPU node, you could control that through the partitions. And actually in Slurm, this can be done automatically. So you could request a resource, let's say a GPU resource, and then the scheduler should find out automatically what's the best suited partition. Or you will see later, you can specify also explicitly what partition you want to use. And under the hood for each partition, you have a queue, which is basically then responsible for enqueuing the jobs or getting the jobs, and then they are served in the order accordingly.
Is it fair to say that partitions are queues, basically?
Similar to queues, yeah. Yeah.
And do they need to be like, I'm not sure if, but do they need to be homogeneous? Like each partition has a homogeneous set of nodes, or that doesn't matter?
That doesn't matter. I will give some more examples. It doesn't matter. You can define the partitions. I don't have exact example of how the definition is done, but I have some partition examples. So, okay, this is summary of the resource requests, what you usually will see in the jobs. Okay, this is more on the CPU side. There are further things what you can control with plugins for GPUs and so on. But yeah, this is how usually you can control how many cores you get and so on, and how much memory per CPU and so on. Now back to the partitions. So for example, if you want you could, this example, which I took from NREL, it was with 2 islands. You had an island, roughly 100 nodes, which had, let's say, hard drive capabilities above 1 terabyte. So you could basically group them, and every job request which wants to use, which needs file system bigger than 1 terabyte will be served by this. Another example, you could group by memory. So you could tell at least make a queue or make a partition basically, which will cover all requests with for jobs having more than requiring more than 96 gigabyte of memory. And in that you can have 2 clusters, as you see. So one with 192. It doesn't have to be homogeneous, but you can bind them in 1 partition, 1 queue. Both will fulfill the requirements. This is just a simple example. And this is extended further. You can have a 3rd one with GPUs. And the way how you specify your requests, you add these parameters to the sbatch command or srun command. You tell explicitly, I want 500 gigabyte of memory, or I want 20 terabytes of storage. And then Slurm will find out which one of the partitions is best suited for this job, basically. Yeah, they are actually recommending to do explicit resource requests, but you have also the possibility to choose the partition on explicitly. You can list them, so you can you can always see what are the available partitions, what kind of how many nodes you have inside. And then there is an argument -p, I think, what you can pass to the S batch to use the explicit partition, but they are not advertising that usually. Yeah, this is the example. Basically, you have the standard srun command, you have a time parameter, how many nodes, you want 4 nodes, basically, with that capacity of memory. So this is how you request it. Or if you want a batch job, or if you want a batch job, the only thing what you need to change, you do this srun to sbatch, then it will basically push it on the queue and give you the control back. Right, and here another example, basically with GPUs, you want 2 GPUs, basically to use 2 GPUs on 8 nodes with two GPUs each. So this is how you can request it. And in the background, it will choose the partition, or explicitly you can specify -p. Yeah. Yeah, I think I'm a little bit quick. So this is the basic interface. As you see, it's very simple, very intuitive. This is a little bit the difference to the Kubernetes, where you have descriptions through YAML. They are a little bit verbose. And for batch job processing, at least this kind of Slurm stuff is very, very easy to use. It's basically a client, then you have your shell script and it's executed. Yeah, and I have some open discussion at the end. So yeah, I have maybe questions to the community, or if somebody already have made thoughts or some experiences, if those both worlds can be combined. So the whole batch, of course, there is the way to rewrite everything from scratch from Kubernetes, but can't you extend, for example, Slurm for Kubernetes, run Slurm on Kubernetes, which I saw in some cases, right? Yeah, this is my first question, if you had some experience with that. Yeah.
I have a question.
Mm-hmm.
Can a job specify multiple partitions? Let's say I would say GPU 2 and memory something, and Slurm is gonna do the intersection of 2 partition and find the common nodes and stuff like that.
If you have multi-powers, yeah, you can specify basically a minimal memory and to combine resources. This is possible, yeah.
Okay, so there are the intersection nodes are selected in that case, right?
It will select the node which fulfills basically both requests.
Okay.
Yeah. It cannot run if you, yeah, it will throw an error if it doesn't find a node without sufficient memory or without a GPU.
Got it. Thank you.
Maybe this is Shane Kenner from NERSC Berkeley Lab. Maybe just, I wanted to comment that one thing that I'm not sure was covered, and maybe it'd be worth having, a presentation separately on that, is a lot of what Slurm's designed to do is give a policy kind of framework where the resource provider can put priorities on how jobs are scheduled. So you might favor large jobs over small jobs, for example, or you may give certain types of jobs priorities over others. Really what it's designed to do is, typically you have a backlog of work that exceeds the amount of resource you have at any point in time. And so it's trying to make decisions about how to schedule that workload. And where it can get challenging is you might have, if you need to schedule a really large job, then you have to start putting aside resources so that you can run that, right? So even if you have a job that's could run, you may defer it because you need to get the resources to run that big job. And so it has this concept of kind of making reservations that are kind of in the future, where it's going to plan to run, a certain job based on its requirements. So a lot of its capabilities are in how it makes those scheduling decisions.
Yeah, it has very sophisticated schedulers, and the reservation systems are also nice. Yes, so you can basically specify as an argument that you want to use a reservation. So this is one of the nice features. Yeah, so there are a bunch of very good ideas inside Slurm. The partitions, the limits. I think the whole accounting is very sophisticated already, very mature already.
One question I have here is, in a typical, like you did, I think, give examples from an actual deployment. Like, how many partitions do you have? Like, again, in my mind, partition, it resembles a queue. Do you usually like have, like, I don't know, tens or thousands of these partitions, or a lot less? Partitions being overlapping? Do they map to teams? Like, how does that whole thing usually, like, what is the typical pattern?
What I saw in the past on some of the big systems, HPC systems, they try to group the resources. Usually you don't get a lot of partitions. You have maybe 5-10 partitions, basically. Some of the what you usually have on these big clusters, they organize them in islands, because islands are, if you stay within an island, you might have basically you might be on a single rack or something like that. So in some cases you have the possibility to access an entity of the data center through a partition. So basically, through taking this partition, I will be running on an island which is very well connected, let's say, and will give me very good latency in terms of communication. Right. So you can have this as one thing. Then you might have different types of hardware. So you might want to have partitions dependent on memory. So you will have, let's say, standard nodes with having 128 gigabyte memory available, and then you have a fat island or a fat partition which does 1 terabyte memory. It's another example. So there are not so many. Usually they are within a tens of partitions. They're not thousands or something like that.
So I have a question. So let's say if somebody does not specify partition, can they be scheduled on any nodes irrespective of like whatever island they are on?
No, the administrator has some level of control. There is most probably a default pool where the jobs will land. So you will have a default pool, or the administrator has the power to define the default pool where all the jobs will go. You can limit the access also to the partitions, not give access to everybody for the fat nodes or something like that. This is possible.
Okay, but the job still can get scheduled on heterogeneous kind of nodes, like somebody with high memory and somebody with low memory. That's possible. That's not explicitly denied.
If the administrator did not disallow it, it can be scheduled, but okay. Yeah, the administrator might turn it off. So
got it. Thank you.
I have
yeah, so
sure that others have a chance to. Are we running out of time?
Sorry, I did not.
We're almost out of time. Any other questions from the community?
I want to tackle on these questions in the slides. So the slides are suggesting that Slurm is the resource manager and Kubernetes is the interface. But I was thinking whether that makes sense, or it would make more sense to do it the
Yeah,
other way?
this is. I wanted to. I did not speak about it too much, but in my company, we are looking at benchmarking and how to approach cloud native benchmarking. So a team had the idea to look to classical CI tools, like Jenkins, run Jenkins job and stuff like that. And yeah, for me, I don't know if this is a good model because benchmarking usually can be done as a batch job. If the benchmarks are mature and you know that they are stable and running, you can shoot them in a queue, right? Go to sleep and come back and get the results. It's very well suited for batch job processing. So I was thinking basically how can we do benchmarking in my company for Kubernetes by maybe reusing some ideas from Slurm. And the idea what we are exploring, can we use Slurm basically to spawn Kubernetes clusters? As basically the benchmarks can vary. We want to benchmark, let's say, a cluster of 4 nodes, 8 nodes. So you can expose the nodes, make them available through Slurm first, and then Slurm allows you to start a job, and in some sort of prolog script, you can provision a Kubernetes cluster on the allocated nodes. This was the idea. And then you just run the benchmark, gather the results, and at some point the result or the job is completed. So you could theoretically combine both worlds, at least in this example for benchmarking, and make it, but this is in the case where you want to test maybe the whole Kubernetes system. In other cases, you might have just one Kubernetes cluster and you just want to submit batch jobs. You don't need all this overhead. So most probably it's not very efficient way in terms of provisioning and so on, but it should be possible.
One question related to all or nothing scheduling. Do you, like for larger jobs, are there like times where you would have resources being set aside while Slurm is trying to accumulate the amount of resources required for the all or nothing job? And it like, for how long does it do that? Like, I'm just trying to understand how it implements all or nothing, or trying to minimize, maximize, you know, or minimize the case where you have as resources set aside that can be used while accumulating what's required.
And maybe I could comment on that. Yes, it'll definitely do that. So that's what I was talking about earlier, is it'll make, if it's trying to schedule a large job, it can create sort of automatically a reservation out in time when it thinks it's going to be able to have those resources available based on the time limits that have been specified for all the different jobs. And so it'll say, you know, I think at 6 o'clock, I'll have all the resources to run a 1,000 node job. And it'll make that reservation. Now, if a job comes in that's shorter than the time between that and the reservation, it'll slot that in. So it's called backfill scheduling. So it'll try to make efficient use of the resources that it can without, you know, interfering with running that large job when it's planning to.
But that assumes that all jobs declare when they're
They have
started.
to.
Oh, they have to?
Yep.
That's like
They have to declare a wall time is, they don't have to, but typically a wall time is either specified by the job or a default is applied based on what partition they go into.
What is the typical that you see? Like, is it?
It can be hours to days, but typically, you know, many days starts to get towards the limit of what a typical HPC center might, you know, allow.
I'm just like, there could be a case here for like users trying to game the system, right? Always setting something that is like break things. I'm wondering if that. Yeah.
They will try to game the queues to try to get their jobs to as fast as they can, but it's within the limits of how the policies have been configured. So there's constraints on that. like a smart user will sit there and say, like, I can fit my job in that backfill slot. Let me size it the right way so it'll jump in. Others they just want it to run at some point. They'll submit it and they'll wait for it to come out the other side.
That's the start time, but like the length of the job, that's something hard for users to estimate, right? Like how long my job is going to run, because it depends on the resources that I will get in terms of like.
Well, the resources tend to be very consistent, so you kind of have a feel for that. But you're right, it can vary. It can vary more because of things like IO congestion or things like that. But they'll typically put in, the expected time, and then they'll put in some safety factor. They won't get charged. They only get charged for what they use typically. So it's more about just trying to get the time right so that it'll schedule sooner than otherwise.
Okay, thanks.
Yeah.
Yeah, this is another thing which I did not cover, the charging. So they are usually in the HPC data centers, they connect that with some sort of budget. The users have budget of hours, compute hours. So you can make it automatically that the compute hours are then deducted based on the actual used compute time.
Question, does Slurm save the state of the job? Let's say I'm running a job and by this time the job needs to be completed. If the job is not completed, then save the state so that I can resume tomorrow the same time and finish the job.
Yeah, this goes into checkpointing. Usually a lot of the applications are doing, or the HPC applications are trying to support checkpointing. It depends a little bit also on your code. If your code supports checkpointing, you can make checkpoints in time and basically start from a certain checkpointed state later. So it's not completely automatic that you make a copy of the memory and then you can restart. It's not a virtual machine or something which is running, so your application has to support it.
Okay, thanks.
Yeah, thank you very much, Atanas, and Shane also for backing Atanas with some of these questions. We're 5 minutes late, I guess. That was really great. Please, like, if you have more questions, maybe tag Shane or Atanas on the working group Slack channel. And maybe, as some mentioned on the chat, we can invite also people from SkidMD. I did meet with them before, the SkidMD folks, and mentioned to them that we have a working group in case. So we'll try. I hope we represented them well, I guess, here with this presentation.
Yeah, most probably they can give us at least some insights if they are looking into Kubernetes enabling and stuff like that. So it will
right, there are things, for example, like how Slurm is planning to support like auto scaling, for example, in cloud environments. I guess there is there is a ton of work there, I guess, happening right now. Yeah. So that would be also interesting, because everything that we've discussed so far kind of works well on an on-prem cluster, but I have a ton of questions of how this is going to work on the cloud.
Yeah.
The elasticity and like auto scaling, all these things, and the various amount of resource types that you have that you don't typically have on an on-prem cluster, where you have mostly homogeneous machines. All right, thank you all. Meet in a couple of weeks.
Thanks.